Now, in doing this, and it's even less of a chance that they're going to do it and still be profitable. Now, in doing all of this, we say, well, what's the big deal here? So the software isn't quite what I had, you know. But with 1.25 billion computers in the world, if we lost only $5 a day because it doesn't work with the printer we have, it crashes, it has spam, viruses we can't fix, it doesn't support our language, you know, by the time we do that for the 1.25 billion computers, we're wasting $6.5 billion a day. That's almost enough to run a small war in some foreign country. And, you know, or we could actually create, you know, inoculation for polio, wipe it off the face of the earth. Now, I'm not so much a Pollyanna to think that we're going to be able to get that cost of $5 wasted every day down to zero. But what if we could make the software change it to meet our business needs a little bit better and reduce it by $1? Now, that's a big number. A lot of people have problems thinking about that. But let's say we have a company with a set of knowledge workers. Maybe it's a telephone answering firm or something like that. And each one of these people have a computer sitting in front of them, 300, and they each waste 15 minutes a day futzing with their computer. That means that basically it's like 9 people of those 300 just never came into work. They didn't call in sick, didn't call in vacation, they just didn't show up. And if you were a manager, you'd be absolutely ripping about that. This is the hidden cost of proprietary software. Now in Rio de Janeiro, there was a small company that was investigating the rainforest for new plastics, new materials, new stuff like that. And to do that, they needed geographical information software, GIS. This was typically supplied by some large companies around the world, and their software was breathtakingly expensive. Now there's 2 types of proprietary software. There's expensive proprietary software and breathtakingly expensive proprietary software. And this second one was that, $500,000 a copy for the software that they needed. And they had the money, they needed 9 copies, $4.5 million, and they went to but the problem was, the software was only in English, and believe it or not, these people in Brazil only spoke Portuguese. Would you believe that? People that don't speak English, what's wrong with them? They must be stupid, you know? So they went to the big company and they said, hey, please, you know, we buy $4.5 million worth of your software. Could you please create a version that prompts in Portuguese? And the company said, no, it's not in our best business interest. Remember that phrase, folks. Remember, it's not in our best business interest, as opposed as go to the company producing the software. What about the business interest of the customer? That's the thing. There's the problem, okay? And so the little company went to an open source developer and said, look, we don't need all the functionality of this big piece of software. We just need this little bit. Could you do this for us in open source? And the open source developer looked at it and said, yeah, I think I can. We use a project called OpenGIS. We use a project called GNU-Plot to plot out the maps you need, Postgres SQL to hold the data in it, and Python to tie it all together. And in 3 months, for a cost of $380,000, the little company had the software they needed, and it prompted in Portuguese. Now, here's the test. What was the value of the software produced by the open source developer? 4.5 million. Good guess, because that's what they would have had to pay, but they only would have gotten the software in English. That's another guess. Remember, they only paid $380,000 for it. Because another good guess would be $380,000. I mean, the developer made $380,000 for 3 months worth of work. That's pretty good. I wouldn't mind that. And in Brazil, that's kind of like double that because their cost of living's lower, okay? But no, I think that this software was infinitely valuable because without it, the little company couldn't exist. And there's a difference between return on investment and cost of ownership. What else is wrong with binary-only software? Well, we can't see how it works. How do you know it's actually solving the problem that you want to solve, the way that you would have solved it? I was working at a university one time where this professor had done a doctoral thesis based on some mathematical statistical studies. And as he was doing his presentation to the people in the staff of the college, because he just received his PhD, I looked up on the board and I realized he'd used the wrong statistical formula and nobody had caught it. He was using formula used in large sample sizes for large populations. And he really used a very small sample size for a large population. I leaned over to the Dean of Instruction sitting beside me who was resting his head like this. I said, Dean, he used the wrong formulas. Dean says, I know. I took statistics also. So how do you know that they're actually using the right software and the software is correct if you can't inspect it? You can't learn from the existing software you're using. You can't learn how to make the software better. It's very also hard to do research with closed source projects. Now, if you're in a university and you're doing research, a lot of times you'd like to share the results of your research with somebody else so they can help to collaborate with you. Well, yes, you could write out in a paper form to say these are the formulas we used and this is the procedures we did. But how much easier it would be to be able to just simply say, here's the source code that we used to do this, can you help me with it? That they wouldn't have to redevelop that. And it's not just about the source code of the project itself. When they were trying to understand the Human Genome Project, a lot of the people working on that were storing their data in a well-known, large-scale commercial database whose name rhymes with Oracle. And to be fair to Oracle, they were right up front that their license said that you couldn't take the Oracle database and simply give it to another person because that violated your license. So that meant that you had to unload your Oracle database, unload the data from your database, put it onto some type of medium, and transfer that, and then the people who got it had to load it into their Oracle database in there. Well, that's one thing when it's maybe a gigabyte or 2 gigabytes, but when you're talking about a petabyte of data, that's a lot of unloading, folks, okay? And reloading. And so by using MySQL, they were able to say, here's the whole disk. Boom, take it. And this made it a lot easier to exchange the information back and forth. And finally, companies go out of business. You know, I say, and then people say to me, well, Mad Dog, that's why I buy my software from a really large company that won't go out of business. And I go, oh, you mean like Apollo, Wang, Digital Equipment Corporation, Compaq. And even though DEC was bought by Compaq and Compaq was bought by HP, as you make these transitions, product lines die, are retired, and you, the customer who's using this software, is stuck. Now, I believe we've only seen the tip of this iceberg because in reality, a lot of us, a lot of people in the computing industry, which is still a very young industry, we haven't really experienced a lot of what is going to happen as some of these large companies go through and the software that we now depend on goes. So there was another time that a company called Caterpillar Tractor, which was a big customer of Digital's. I was at a trade show. This person from Caterpillar Tractor came up to me and said, we have a problem. It's 1999. And we're worried about the Y2K problem. We wonder if this operating system that you had called Ultrix is Y2K compatible. And I says, well, we retired that product a long time ago. We don't realize we have any customers still using it. Are you using it? He says, well, we don't know. The problem is that we sold this automated warehouse package that had these automated forklifts go through warehouses and put packages up on these shelves and things like that. We lost the records of who we sold this to. We don't know who they are. We don't know if they're still using them. We just know that there may be some people out there with these automatic forklifts going through the factory. He says, what do you think would happen at midnight on 1999? I says, I don't know, but I don't want to be in that warehouse. I got up the next day, I got up on January 1st, year 2000, I looked at the paper, I didn't see any articles about forklift trucks spearing people, so I figured it was okay. So these are problems, okay? And with closed source, the solution to them has been taken out of your hands. So remember, we moved from open source to closed source, and now we're moving back towards open source. It's different now. The hardware prices to create a significantly powerful computer system are become so cheap that people can now afford to buy something to help create this fantastic project. The ability to communicate rapidly back and forth, not just with the internet in your office or your internet in your university, but the internet in your home, allows people to work on this from around the world. There's massive amounts of free code that were available, you know, and then finally Linus Torvalds turned 21 and recognized that the part that was missing was the kernel. And so we started the Linux project. Now, yesterday I talked about the goals of education. If the goal is to create jobs, that's good, but I don't think that's the job of education. I think the job of education is to create a thinking electorate and a thinking workforce and the ability to create knowledge out of data.